Today in front of you, we've got Discover's very own 4248-6650. This one can both act as a lead acid replacement, or you can take advantage of the smart BMS and its reporting capabilities. The 4248-6650, this is Discover Batteries, the largest 48 volt lithium battery. Gone ahead and popped it out of the case. What's left is the cell block with the electronics package on top. And really quickly, focusing on the cell block, you can see that the cells are actually attached in series here as well as parallel. So the current flow is actually going through the cell, whereas alternatively, it's quite common to have just the modules paralleled with a nickel sheet, and that current flow is kind of wrapping around the cell modules. So here you see it going directly through. Also, you'll notice some mechanical structures throughout the battery. These came from a lot of learnings in certifications. So UN 383, UL 1973 and 2271. In order to tie this cell block to the case and really couple a tight mass, as opposed to if the cell block was just floating inside the case, you'll get two masses moving at different frequencies. We've got this structure here to hold it all together so we don't shake apart when you go to shake and bake this battery during certification testing. Also on the end, you'll notice very large plate here. So we're not using thin nickel material. Helps us carry a lot more current, a lot more power, and adds a bit of robustness. So here, you can't quite see it, but inside the cell block, there's an array of temperature sensors. They're also on the solid state relay and the BMS. So that allows the BMS itself to paint a pretty robust picture of what the thermal profile is at any given time. Also, you'll notice that there's no wiring harnesses here at all. We totally designed that out. So voltage, current, temperature pickups and sensors, there's no wiring harness for that anymore. The actual main current path doesn't go through any cables. It's all through bus bar, 72 millimeter squared bar. And essentially what we're left with is the BMS package. Now this I can actually pull right off the cell block and transplant to any voltage variation that we have. All right, so the BMS on this battery is actually composed of two boards. We have the solid state relay and then the main digital board. If I pull off the solid state relay, you'll see a lot more bus bar. So that we're carrying current through the bar as opposed to just the copper on the PCB. Here are a few more comparables. So a pretty standard solid state relay and BMS out of a straight lead acid replacement. So just a few more examples for you. Heat sinks over here, typically not very fancy, no fins, just flat metal bar. Once again, not a whole lot of copper, not a whole lot of material for current to flow through. And finally, just one more that I've got. So typically a lot of the same construction you see, but there's definitely a big difference between the two. Also, you notice that we are internally fused, so just one more protective measure, just in case something goes wrong and you really short circuit a load. All right, let's move on to the BMS. So the BMS here is our opportunity to be more than just a lead acid replacement. So once again, you can use these batteries as just a lead acid replacement, or you can take advantage of all the communications and further features that this board here offers. So we do have our passive balancing, voltage monitoring, current and what have you all here. But this board is what allows us to offer further features and really have an advanced energy solution and not just a lead acid replacement.